Okay, sorry I got cut off there. This is Corey Newman again, going for part 2 of chapter 1 of my thesis on the air defense in New York City. Continue reading. By the spring of 1956, the procedure established for the transfer of atomic weapons from the Atomic Energy Commission to the Department of Defense in an emergency had become a matter of serious concern. A practice alert in June 1955 had demonstrated definite and potential serious delays in authorization and notification procedures. The Department of Defense and Atomic Energy Commission both considered it essential that steps be taken to eliminate all sources of possible delay or confusion in the transfer procedures which might compromise our readiness to react to an attack or threat of attack. Fail-safe missions began with a series of test sorties called Operation Noah's Ark, flown between November 1957 and January 1958. Fail-safe missions began being flown daily shortly thereafter. The Tu-4 Bull bomber, nor the later Bison bomber, had the ability to attack the United States. The Soviet Union did not build these bombers in the estimated numbers that were claimed in the records during the Cold War. The Soviet Union did not have over 1,200 Tu-4 Bull bombers. Pavel Podvig stated that serial production of the Tu-4 began in 1948 and continued until 1952, during which time 847 planes were built. He continued, the Soviet Union never kept its strategic bombers on alert with nuclear munitions. Nuclear weapons for bombers are stored at technical facilities, maintenance and technical bases, close to air bases. A command for increased readiness along with the order to issue nuclear weapons would be issued by the Soviet General Staff. A second order for the use of nuclear weapons would come after this first order. This is when the bombers would be launched with nuclear weapons and proceed to specific points before proceeding to their targets. Paul Braken states that in the Soviet Union, nuclear warheads were held by special KGB units and were not given to the military until the 1960s. The SAGE air defense system was a computerized command and control system for air defense that was developed in the 1950s at the Massachusetts Institute of Technology, MIT. It linked radar data and weapon systems together to more effectively and efficiently fight an air battle against enemy bombers. The SAGE system began as a letter in December 1950 to MIT to undertake a somewhat wider study of the general problems of air defense. The study was called Project Charles, and it came out in August 1951. The Project Charles report, as accepted by the Air Force, and the suggestion that air defense be automated and computerized. The next month, MIT was given a contract to proceed with its suggestions. A series of tests were conducted over the next 2 years using the Whirlwind 1 computer at MIT called the Bedford test. The pre-SAGE system first used the World War II Whirlwind 1 computer at MIT and was initially called the Cape Cod system. The Cape Cod system came into being in 1953. The Cape Cod system was in essence a model of the large scale air defense system. 5,000 or so sorties had been flown against the system to test the whole as well as its components. The Cape Cod system was expanded in 1954. After that, the system was expanded again to increase the coverage with 200-mile range radars between 1954 and 1957. In the summer of 1954, it received its permanent name, Semi-Automatic Ground Environment, or SAGE system. This is called the Experimental Sage Subsector, or ESS. This would provide radar coverage from Maine to southern New Jersey. The Highlands and the Montauk Air Force stations were added in 1954 and provided the southern portion of the radar coverage of the ESS network. In September of 1954, the Continental Air Command was activated. As part of the development of the SAGE system, a new duplex computer was developed called the FSQ-7 and put in a 4-story building in Lexington, Massachusetts. The Air Force decided to put the FSQ-7 computer in a large 4-story windowless hardened concrete blockhouse with 3-foot thick walls at McGuire Air Force Base. Construction of the SAGE system blockhouse at McGuire began in 1955 with the FSQ-7 computer being installed by November 1956, and on June 26, 1958, the first SAGE Direction Center was declared operational at McGuire Air Force Base. The Air Force built 23 SAGE Direction Centers across the nation. The SAGE computer weighed 300 tons and had 58,000 vacuum tubes. It took up the entire second floor of the Direction Center. Its software had 250,000 lines of computer code and was the most complex computer software in existence in 1958. On September 12, 1957, the North American Air Defense Command, NORAD, was activated. NORAD was the joint U.S. and Canadian Air Defense Command for the defense of the North American continent. NORAD began construction on its current headquarters inside Cheyenne Mountain in May 1961, and was completed in September 1964. The SAGE system was in operation until 1983, when it was replaced by the current Joint Surveillance System. The United States developed several types of fighter aircraft for air defense and tactical use between 1948 and 1975. In April 1946, the fighter aspect of national air defense was put under the control of the Air National Guard. This doesn't include various experimental aircraft or training aircraft. In July 1947, Colonel Kenneth B. Hobson, Chief of the Army Air Force Organization Division, developed a wing-based plan. Hobson plans envisioned doing away with the wing as a level of command over several combat groups, and instituting a new type of wing as a combat organization, containing the necessary support elements and intended to operate from a single base. The combat group would be merely one element of the wing, and the responsibility for the entire combat mission would be fixed squarely on the wing commander. Besides the combat group, a wing would have 3 support groups: maintenance and supply, airdrome, and medical. The Hobson Plan became the standard for the Army Air Force in July 1947. This force stayed in place until the 1952 reorganization of the Air Defense Command. On June 11, 1948, the designation of fighter aircraft was changed from P for pursuit to F for fighters. On December 1, 1948, the Air Defense Command was made subordinate to the newly created Continental Air Command, CONAC. Under President Truman, the Air Force was limited to 48 wings, even though Congress approved the 70-wing plan. At this time, ADC only had 7 air defense fighter squadrons. A year later, CONAC had 20 air defense fighter squadrons. In mid-May 1950, the new Secretary of the Air Force wondered why SAC wasn't being given priority as a nuclear retaliatory force, and the air defense fighters were given priority for the protection of population industrial centers. General Enos Whitehead answered that SAC bases, except the one at Rapid City, South Dakota, were virtually invulnerable to Soviet attack because 1. Most of them were in the interior of the United States and should receive enough warning to permit evacuation, and most were located at the extreme one-way range of the Soviet Tu-4 bomber. Besides, General Whitehead did not believe the Soviet bombardiers were sufficiently skilled to knock out 20 SAC bases in a single strike. Further, he doubted that the Russians would have enough atomic bombs within the next 2 years or 3 to mount such an effort. On January 1st, 1951, ADC was reactivated as a major command. ADC then acquired 21 air defense fighter squadrons with a total of 351 aircraft, of which 248 aircraft and crews were considered combat ready. Because of the Korean War, 21 state Air National Guard fighter squadrons were federalized in February and March 1951 to augment the strength of the Air Defense Command. By June, ADC had 44 air defense fighter squadrons with 778 aircraft, of which 525 were considered combat ready. The Air National Guard aircraft were obsolete P-47 and P-51 aircraft of World War II vintage. In May 1952, there was an oil industry strike that grounded the Air Force for most of the month. By the end of 1952, the Air National Guard squadrons reverted back to state control without their aircraft. In their place, the Air Force activated 20 regular air defense fighter squadrons. The Air Defense Fighter Force would continue to grow until it reached its peak during the period of 1955 and 1959, having between 1,400 and 1,500 aircraft on average per year. After 1959, the number of fighter aircraft available would steadily decrease until 1973, when there were 10 squadrons with a total of 135 aircraft. During the 1950s, the main air defense fighter aircraft were the F-80, F-86, F-89, and F-94 aircraft. During the 1960s and 1970s, the main air defense fighter aircraft were the Century series of fighters, the F-101, F-102, F-104, and F-106. With the decommissioning of the World War II Anti-Aircraft Command in October 1945, the Army began planning to put its AAA under State National Guard control in 1946. Plans are being considered in the reorganization of the National Guard for approximately 72,000 AAA troops and 45,000 harbor defense troops. New York State was to have 2 AAA brigades, 5 AAA groups, and 9 AAA battalions. Stephen Moeller, in Vigilant and Invincible, stated that the Army's portion of continental air defense in the late 1940s consisted mostly of National Guard units. In 1948, the National Guard was called upon to furnish 123 anti-aircraft artillery battalions to be ready by 1952. Kenneth Schafel, in his book, The Emerging Shield, stated, Before the Soviet atomic bomb explosion, almost no Army anti-aircraft artillery units were on air defense duty in the United States and Alaska. On July 1st, 1950, the Army Anti-Aircraft Command, ARACOM, was formed in the Pentagon, commanded by Major Willard W. Irving. The main AAA guns were the 90mm gun and the 120mm gun. The 90mm gun fired a 25-pound shell to a maximum height of 36,000 feet. A good crew could fire the gun at a rate of 25 rounds per minute. The 120mm gun weighed nearly 30 tons. It fired a 50-pound shell to a height of 47,400 feet. A good crew could fire the gun at a rate of 12 rounds per minute. In 1945, Bell Telephone Laboratories wrote a report to the Army about developing radar-guided missiles that became the Nike program. The Nike program was named for the Greek goddess of victory, Nike. In 1946, the Army set up the Army Air Defense Center at Fort Bliss, Texas, and tested captured V-1 and V-2 rockets at the nearby White Sands Missile Range under Project Paperclip with former Nazi rocket scientists. A contract was given to Western Electric Company on September 21, 1945, by the Army for nearly $4.9 million to develop a missile that could reach 60,000 feet in altitude and have a speed of 600 knots. The Nike Ajax was the first AAA missile that was developed and deployed at numerous sites around the United States. The Nike Ajax had a range of 30 miles and could reach altitudes of 70,000 feet. The missile could reach speeds of Mach 2.8 or 1,679 miles per hour. The Ajax missile was 21 feet in length, 1 foot in diameter, and had 3 conventional high-explosive warheads. The missile was launched with a liquid-fueled booster. Nike missile battery sites were split into 2 sites: a control site that had the radars and administrative functions of the battery, and a launcher site that had the missile launchers and maintenance functions of the battery. The Nike Ajax missile sites were set up in a ring around select cities and SAC bomber bases during the mid-1950s. These Nike sites were sited within 20 to 25 miles of the city or the SAC base they were to defend. The Nike Ajax was the first guided missile in the nation. It was directed to its target by means of a set of radar beams. Each missile could attack only one target. The Nike sites were designated by an alphanumeric code by the city they were to defend, such as New York, and were numbered on a ring 1 to 100 in a clockwise formation. For example, the Nike site at the Highlands Air Force Station was designated NY-55DC. This site was at the bottom of the Nike Defense Circle. The next AAA missile that was developed was the Nike Hercules. This was the first nuclear AAA missile developed and deployed in the United States. In February 1953, the Army began planning for the next generation of Nike missiles. In April 1955, a contract was awarded to Western Electric Company to develop the Nike B, as it was then called. On April 25, 1957, the Nike Hercules destroyed its first drone over the White Sands Missile Range with a conventional T-45 warhead. The Nike Hercules had a range of 75 to 125 miles and could reach altitudes over 100,000 feet. The Hercules missile could reach speeds of Mach 3.65 or 2,707 miles per hour. The Hercules missile was 41 feet in length, 31 inches in diameter, and had either a nuclear or conventional high-explosive warhead. The missile was launched with 4 solid-fuel rocket boosters banded together behind the missile. It was adapted to the Nike Ajax launching system. Command and control of Nike, the manual system and missile master. In 1945, the Army Signal Corps began Signal Corps Project 414/A as part of Project Nike. This project was initially developed to coordinate the fire between several 90mm gun batteries. The T-33 fire control system was a reworking of 2 World War II pieces of equipment, the SCR-584 radar and the M9 director. The SCR-584 radar had a range of 35 miles. The T-33 control system was put into production by 1950. After 1950, the SCR-584 radar was replaced by the TPS-1D radar with a range of 120 to 160 miles. The T-33 system was renamed the M-33 Fire Control System. During the 1950s, the Iraqcom used the World War II manual plotting system to track and plot targets using a flat grid system called the Geographic Reference System and track stands. At the Anti-Aircraft Operations Center, AAOC, usually located at a brigade headquarters, was a trailer that had the associated radar scopes of the TPS-1D and the flat plotting table. The Semi-Mobile Manual Operations Center was designated GSS-1. This manual plotting system was in operation from 1952 to 1960. In 1949, the Signal Corps Engineering Laboratory No. 4 was set up at Fort Meade, Maryland. Between 1949 and 1953, as part of Project 14/A, the engineers and scientists at Fort Monmouth came up with the AN/GSG-2 anti-aircraft system. This was the prototype of the Missile Master. The major part of the AN/GSG-2 was a multi-weapon automatic target and battery evaluator, or MATAB, which was created by the Burroughs Corporation in their Paoli, Pennsylvania Research Center. In October 1953, the Army McCarthy hearings began an investigation into supposed communist infiltration at Fort Monmouth, New Jersey, headed by Senator Joseph McCarthy. One of the engineers of Project 414A was Aaron Coleman. During the Army McCarthy hearings in New York City on October 23, 1953, Lawrence Friedman testified in closed session before the Senate Permanent Subcommittee on Investigations of the Committee on Government Operations. Mr. Friedman was asked about Aaron Hyman Coleman. Do you know Aaron Coleman? Mr. Friedman answered, Aaron Coleman was a project engineer on 414A project. I was on the 414A program. I was one of the mechanical engineers on the program. Senator McCarthy asked, as you perhaps know, the Army intelligence raided Coleman's home and picked up some 43 secret documents which would be of great value to the enemy. Do you have any knowledge of his having removed these documents? Mr. Friedman answered, no, sir, no knowledge whatsoever. Shortly after this, the Army would move the remains of Project 414 that were at Fort Monmouth to Fort Meade, Maryland. The GSG-2 was a computer that can make 136,000 calculations within 0.6 of a second, that could track 30 targets and coordinate the firing of 20 batteries. This computer was